Good afternoon everyone and welcome to this webinar on hybrid turf products. My name is Eric O'Donnell. I'm the Managing Director at Sports Labs and one of the directors of ProPitch. I'm joined today by Sean Ramsey, who's our Laboratory Director. Sean has 30 years experience of testing turf products, so it'll be fascinating to hear from him what's important about these textile-based products. Later on we'll be joined by Ian Craig and Dean Gillespie of ProPitch, who will generally talk more about the in situ performance of the turf systems. So obviously the focus is textile-based systems. We will touch on stitch systems, particularly on the yarns, talk a little bit about the different products that are available, and we'll talk about how we test them in the laboratory and what's important about the performance, the key performance parameters of these systems for durability and even for maintenance longevity. And then we'll talk about the impact of the different systems on the performance of the pitch. Further, we'd like to talk a little bit about sustainability. It seems to be on everybody's agenda at the moment, and it's we shouldn't ignore that topic. And hopefully we'll have plenty of time later on for comments, questions. And what I would do is I would encourage you to use the question and answer function on this platform to put your questions forward, and you can do that at any time. We have a moderator who can collect up the questions, and at the appropriate point in the presentation he will be able to put forward your questions, and we'll address them at the end of the formal part of this presentation. So before I hand over to Sean, I'd just like to say a little bit about the plethora of textile-based products that are out there. Clearly now we are seeing a lot of different manufacturers moving into this space and producing their own version of either a textile-based, almost a formal carpet system, or a lay-in-play system. So there's a lot of activity, and as you can see here that there's a variety of different approaches. You have the traditional backed turf, which is quite like a 3G turf system, where you have a very open framework, which is the backing material, and you punch the yarn filaments through that, and you're with some sort of glue. And then you have a much different system, which is based on maybe a polyester grid, and the yarn filaments are either woven onto the framework, generally speaking, or they can be fixed using bands of glue, and there's an example of that in that slide, so you can see it's almost a hybrid of a hybrid. So as I say, there's a few companies moved into this space. There's even a variety of stitchers out there now. There used to only be one, now there's a few, and you know, we recognise that in the market. It's become quite competitive. There's the more traditional backed hybrid grow-in systems, which are usually laid in situ. They are dressed with the root zone, and you would seed them and grow them in their final location. And there's been some movement towards a more dynamic system, a more agile system, which is lay-in-play, where you grow the system in a nursery or off-site, and it can be brought in at very short notice and be played on very quickly after it's installed. And that's the lay-in-play systems. And then there's other reinforced systems out there which are, you know, air fibre, and they've been around for a long time. And it's, make no mistake, you know, hybrid textile-based products have been around for a long time as well. They've become very popular recently, but I think as far back as 20 years ago there was a hybrid textile-based system in the marketplace. So what I'm going to do at this point, I'd like to hand you over to Sean. Sean's going to dive into all the technical issues with testing these products, and you know, what are the important key parameters we're looking for, which affect ultimately the performance of the product on the pitch. So without further ado, Sean, over to you.
Thank you, Eric. So what I'm going to cover in the next section is what are the tests that we can carry out on these hybrid systems, and can we use these to identify their ability for performance and durability. Shown here is a table detailing all of the tests that we carry out on the hybrid systems. This includes the individual yarns themselves and the full construction of the system. To define a suite of tests that's suitable for hybrid systems isn't easy, given all their differences. But as you can see, this list is pretty comprehensive. There are also additional tests that we can carry out in the systems, such as phytotoxicity, yarn UVB exposure, which uses a wider spectrum of UV, biodegradability, and compostability. And we'll cover some of these items during the webinar. So what are the key tests that we should be looking at for hybrids, and how are these tests carried out? I'm going to list the tests that we think are important, and after which I will explain each in a little more detail. First up, yarn UVA. The yarn's ability to resist UV damage. Next, we have the full identification of the hybrid system. Then we have tough withdrawal. How well are the fibres locked into the system? And then we have carpet tensile strength. And finally, toxicology. This can be done on both the yarns and the backing materials. So how do we carry out these tests in the lab? And what results should we be looking for? Let's start with the yarn UVA exposure test. This is tested in accordance with FIFA method 10 from the FIFA Handbook of Test Methods. Each yarn shape and colour require testing for UVA, and there are many yarn shapes and shades of green, some of which you can see here. The yarns are loaded into the UV cabinet, as you can see in the plate in the centre, and they're subjected to repeated cycles of UV and condensation, with the 5,000 hours of UV exposure taking up to 7 months to complete. The tensile strength of the yarns is measured before and after the 5,000 hours exposure, and the change in tensile strength is calculated. Currently, FIFA and World Rugby require 3G systems to meet maximum 25% change. The change in colour is also assessed and categorised using a grayscale of shade. Included in this test are the yarn dimensions seen here in the picture, along with the melting point using the DSE machine. The outcome of this test is that yarn is shown to be UV stable with limited to no colour change. Then we come to the hybrid system identification. In these tests we measure all the parameters that make up the system. There are various test methods used in assessment of each, and these are shown here in the table. Using these test methods, we can measure the total mass of the system, the number of tufts, the stitch gauge, the stitch rate, the pile length, and the pile mass. We can check these values match a manufacturer's declaration, and they are within allowed tolerances. We also test the yarn for defects, dimensions, and melting point. Not only to identify the yarn, but we can also check that it matches any existing UV test report to ensure that it's the same yarn used and therefore should be of the same quality. Next, we can look at tuft lock. This measures how well the yarns within the tufts are secured into the carpet system. This is carried out in accordance with ISO 4919 for both unaged and aged test specimens. The aging process consists of placing the test specimen in a water bath at 70 degrees C for 14 days. They are then removed, left to drain and dry. The tough lock is then measured and compared with the unaged values. This is to represent the potential reduction in tough lock during use from the environmental conditions, heat and moisture. Here you can see a tuft hydraulic test being carried out in the laboratory, where the individual tuft is being pulled away from the secure carpet system, and the peak value of force recorded for this test. Albeit there are currently no requirements for hybrid systems, for 3G systems, the EN 15330 standard requires a minimum value for both unaged and aged tuft lock of 30 newtons, where FIFA and World Rugby require a minimum value of 40 newtons. We've seen a large range of results for the hybrid systems we've tested, and some interesting results after the aging process. The question is, would the EN minimum value of 30 newton be more applicable for hybrid systems, given their construction? Or should we be looking at matching the FIFA and World Rugby requirements of 40 newton? The tuft lock is crucial for hybrid systems, especially during routine pitch maintenance, any treatments of the surface that may be required or can influence the condition of the carpet, and of course, during the renovation process. The renovation process could be quite aggressive for the yarns, and we're currently looking at replicating this renovation process in our laboratory on a full hybrid system to try and measure the effect on the yarns. Next, we can look at the tensile strength and elongation of the hybrid system. This is carried out in accordance with EN 13934 Part 1. The testing itself consists of cutting out test specimens from the hybrid carpet 50mm wide and at least 250mm in length. These are conditioned in the laboratory prior to testing, and then they're placed in the tensile machine as shown here in the pictures. They're then pulled apart to determine the maximum force and elongation. Test specimens are prepared from both directions of manufacturing, the warp and the weft directions. The maximum percentage difference between the two directions is then calculated. This value would need to be within any set requirements. The tensile strength in both directions that we've currently recorded in hybrid systems can vary a lot depending on the type of construction. The testing can also be carried out on unaged and aged test specimens to also assess any potential loss in strength during time and use. Again, currently there are no requirements for hybrids, but we can compare these with the requirements for 3G systems. EN 15330 standard requires a minimum value for carpet tensile strength of 15 newtons per millimetre and less than 30% difference between the two directions. Rugby require a minimum of 25 newtons per millimetre, also with less than 30% difference between the direction of manufacture. We have seen hybrid systems that can meet these requirements. Our final key test from our list to measure is toxicology. The hybrid systems can be tested for heavy metals to measure any potential issues, any leaching into the root zone, which could in turn impact the natural grass growth and health. I won't go into too much detail about each of these, but here you can see the list of items measured and the corresponding test methods shown in the table. This list is based on the current requirements for 3G systems. So, what about stitch systems? Can these be tested? And if so, what tests can we actually do? The systems consist of yarn being stitched down into the pitch up to a depth of around 200mm and therefore have no textile backing as such. These yarns consist of two types, polyethylene and polypropylene yarns. The yarn itself can be tested for a number of items. We can test it for the UV exposure up to 5,000 hours, same as previously mentioned, where we measure the change in tensile strength and colour change after the 5,000 hours exposure. We can then measure the dimensions of the yarns and their melting point in the DSC machine to ensure it matches the information in any corresponding UV test report if there's one available. We can also measure the yarns for toxicology, as per the textile-based systems as well. Which leads me on to Ian, who's going to talk about phytotoxicity, which I'm glad I've actually managed to pronounce properly this time. Over to you, Ian. Thank you.
What we need to remember with a hybrid turf is that we are still essentially looking after a natural pitch. We're looking after natural turf, and it's critical that the health and performance of that turf itself is still optimal. With the hybrid reinforcement, what we're looking to do is improve the performance of that natural turf. With any hybrid system, be it a stitched or carpet-backed system, what we're essentially doing is introducing foreign substances, foreign materials into the growing medium of the grass plant. And what we're looking to do is assess any potential adverse effects that these substances might have on the health and overall performance of the grass plant itself. So what we're looking to do is set up some trials with hybrid turf versus a control with just the grass itself and the growing medium, and look for any potential differences, initially starting with seed germination through to seedling establishment, looking at the development of the root system and the shoot itself, and whether there are any changes in shoot mass or root mass and root depth. Root development being particularly critical on, for example, a football pitch. You know, the deeper the root system, the more stable the turf, as well as the overall health of the plant, which is highly dependent on a strong root system. So we're looking to assess particularly the development of this root system, and any, again, adverse effects that might come from the inclusion of the hybrid system. Obviously, with a carpet-backed system, there is an actual physical barrier between the grass and the soil itself. So the aim of these trials really is to assess any potential effects the inclusion of this system may have on the development of a suitable root system. In terms of toxicology, we obviously need to be aware of the degradation of these systems over time, with particular attention, I suppose, to the biodegradable carpet backings. What we need to be aware of with these systems is any potential products of that degradation, which will be in the form of soil leachates that can then be taken up by the plant. We need to understand what these products are, and again, any potential adverse effects that they're going to have on the overall health of the turf.
Well, thank you very much, Ian. I'd never even thought I'd have to try and pronounce phytotoxicity, never mind actually learn what it's about. So just before we move on to Dean's piece, it'd be very important to talk about some of the construction processes and measurements that should be taken before you actually lay the hybrid turf system down onto a pitch. And we use a process of things called key stage inspections to make a site visit to perform measurements or do tests at key stages in the construction process of a new pitch or when it's being refurbished. And it goes without saying there are certain items that are very, very important. Things like water permeability or the infiltration rate on the layers that are put down, the slope and dimensions of the area, so that if you're having a fall installed in the pitch, then that's it's trimmed to the design levels, and the drainage layout, and which should really be designed based on the infiltration rates on the soils in that area, and the evenness that's presented prior to laying the surface, which is very important. You don't want irregularities in the surface which are transposed through to the plane surface, and then you've got to do remedial works post install, and things like the stability of the soil, so the stiffness and the bearing capacity, the particle size distribution of the sand, which is is key to not only sustaining healthy growth, but to make sure the pitch does have a good infiltration rate going forward. And do a visual assessment, make sure it's not actually, there's no thing that jumps out as being a problem. So these are the kind of things that we would be advocating at the construction phase, and there's more information available on this offline if anybody wants to know more about how you would tackle testing and measurements to deal with these topics. So with that, I would like to hand over to Dean Gillespie now. Dean's going to talk more about the in situ performance of hybrid systems, and maybe give us some insight on a few problems which from these do's and don'ts black book. Thank you. Over to you, Dean.
Since the introduction of hybrid pitches back in the 1990s, it is believed that hybrid pitches have helped improve the speed of football. A well-maintained hybrid pitch will give the player a much better feel of the surface, improving the energy restitution and the shock absorption of that surface, which can make the surface faster and less tiring, as opposed to the old natural constructions where they can be quite saturated and quite boggy come winter times. Hybrid pitches are without doubt the go-to recommendation for any major tournaments, as it helps mitigate risks. However, they have to be well maintained. The interaction of players' footing with the fibres is key to the successful hybrid pitch. These are some of the examples we've faced over the years, where obviously the interaction of studs is no longer the case, and the players' footings happen to slip quite often. So you've got one pitch in the top left where they decided to overturf the pitch and bury the fibres. The company we worked for at that particular time believed that that was still a hybrid pitch because the roots then were tying in with the carpet. This is not the case. The top right, you can see the goal mouths are thinned out. They would probably be better off cleaning that surface off, lifting up the fibres, and then applying a light dress in the sand again. And just below you can see where we've done a rotational traction measurement, and you can see the fibres are slightly buried, so therefore there's not much interaction with the surface there. Keeping the fibres present on the surface is the key to success. Maintenance of a hybrid pitch is without doubt the key to its success, ongoing maintenance rather. I've heard some people saying that hybrid pitches make groundsmen lazy. This is not the case. If you do not keep that organic matter off that surface, that hybrid pitch will fail. So therefore, your ongoing maintenance is the key to the pitch's success. What we recommend is using things like a Euro-rake through the growing season. If you're not using a Uni-rake, using scarification machines, obviously through the growing season, and you want to manage what you're doing during the winter months as well, because you do not want that buildup of organic matter starting to bury your fibres. The moment you get buried fibres, the moment that pitch can actually deteriorate a lot worse than a natural pitch, weirdly enough. For a successful hybrid pitch, regular aeration is required. So therefore monitor the hardness every month if you can. thatch organic matter layer. You want to keep that down as much as possible, for you want to keep that pitch clean as possible. Fertilizer, your fertilizer uptake might be a little bit more than your old natural pitches, so therefore keep an eye on that. You don't want to be putting on too much nutrients, but you also don't want to be putting on not enough. Water management is important, not to dry out the surface during the summer months, but also not to saturate them in the winter months too. Just making sure you've got the right percentage of water in that surface is key for that success. And then also end of year renovations, that is your platform for your up and coming season. Without this, you're going to have trouble.
Well, thank you very much, Dean, for that very insightful section on the performance of the systems in the field, as it were. So at this point, I think it's very important that we do just mention sustainability, and in particular the issue of recycling textile-based systems, and even stitch systems. I think you know, the debate out there in the greater community about single-use plastics and recycling plastic and saving the oceans, it's an area, a topic that we can't ignore as an industry. And the good news is that the textile-based or lay-in-place systems, you know, once these have been lifted from a field, can effectively be taken to a recycling plant and then broken down into their components, and then these components can be effectively recycled to make new products which can go back into the sector. We're not quite there yet with recycling turf, artificial turf, back into a turf product, but there are associated products that can be made that can still be used in sports. And similarly, with stitch systems, it is possible to remove the yarn filaments from the sand. It's not that easy to do, but it can be done, and there will become pressure at some point from legislators to effectively ban these types of materials and products from being put in landfill or in fact not be recycled. There will be legislation that will force our industry to recycle these products into new products, so that effectively we are not always buying new raw materials to make components that go into sports fields, whether it's the turf itself or benches or dugouts or whatever else can be made out of some of these materials. So I think it's very important to recognise that. So it's early days, but you know, we can recycle the plastic. It's possible. It's possible to do it in the UK, and it's possible to do it in Europe. There are plants available, and as we go forward, there will be more plants and facilities that are set up that can handle the type of effectively waste that we generate from renovating end of use pitches. So that's good news. So moving on, I would like to first thank my colleagues Sean, Ian and Dean for their insightful and informative presentation. At this stage in the presentation, I would like to start taking questions, and if we could maybe have the first question, please, then we can get cracking. Okay, so we've got a number of questions coming through, which thank you very much to all the anonymous people out there who are putting these questions forward. Just before we dive into the questions that have been put forward by those on the call today, Sean, I'm probably going to ask you a few questions from your piece. Obviously, we see quite a variety of hybrid textile-based products coming through the laboratory, and could you just talk a little bit about the variability you see in the performance of these? Because I think when you see different backing systems that are applied, the grids, the more carpet-based products, there must be different tensile strengths, different tough locks, different infiltration rates. So could you just say a little bit about that maybe speaks to why there needs to be some sort of regulation, some sort of standard for these products. So maybe.
Yeah, I mean the products we've seen come through, the woven ones and the heavily textile backed ones, these tend to be closer to a 3G system than the more open and spaced out tufted systems or woven systems. And we can see a big difference, especially in the tensile strength in the two directions, especially given different makeups of the construction. Also, the tough lock can vary a lot as well, depending on how these are secured to the different backends. Porosity-wise can make a big difference as well, depending on the type of mesh or whatever is used as a backing for these materials. So there is a wide range of results and reproducibility on these systems as well.
Right. I mean, given the aggressive nature of some of the renovations that are done, I would imagine things like tough lock, it's got to be very important, because if you're coring off a top layer to re-establish the turf, these are quite aggressive processes that could effectively damage the plastic filaments, and if you damage the plastic filaments, then the turf's not going to perform the same. This is an annual thing that happens, so I would imagine that having some sort of standard around the quality of the yarns is quite an important part of it. You've also mentioned things like the backing materials. There'll be verti-draining going on with your punching spikes through the effectively a carpet system. That's an aggressive process as well. So having a decent backing system that can take that sort of intervention on a regular basis is very important. So what about you mentioned that there isn't a standard. So what are we thinking here for which body, which trade body or governing body, who should be creating a standard for hybrid systems? It's because we haven't got one, and we're testing these systems. They're not failing. We're applying maybe artificial turf regulations to these systems, but probably it's inappropriate. So who do we go to and say that you should be creating a standard for these systems? Because there's a proliferation, if you can say that, of them in the marketplace. I mean, as Dean pointed out, it's the go-to surface now, and they're going in a lot of different stadium venues. So, who should be creating a standard for these systems?
I know in the UK, SAPCA trade body are looking at developing a standard for hybrids, a British standard. And obviously, we'd hope that would go on to be a European standard. And also, the governing bodies as well. I think it's important that these guys get on board and put some requirements, given that they're used in a lot in stadiums, especially the big competitions now that all use hybrid pitches.
Well, we have seen that like the FIFA and World Rugby have started to do some serious work on what they would call not specifications as such, but guidance or standards for natural turf surfaces. And then within that, there is a section that deals with hybrid. I'm not sure it will dive down into the technicalities that you covered in your presentation. I mean, what sort of tough lock we're looking at, infiltration rates and things like that. But certainly there is that work going on, and we might see something being published this summer or maybe later in the year from the likes of these organisations. So that's something that might be a benefit. We're trying to regulate these surfaces, but obviously, we're talking about a much more technical document than just a guidance note. We're looking at what should we accept as a parameter, an upper and lower limit for something. So Yeah, it's be interesting to see if we could get to the EN side of it.
Yeah.
Have it you know, an EN standard for hybrid turf. I'm not sure that's going to happen soon. So why don't we have a look at some of the questions that have come in? We can, as long as they're not too technical, because we haven't got Dean here, to answer some of them. So why is UV stability so important for hybrid systems when most of the fibres are exposed to sunlight? Well, that's a good question. Of course, the free pile is what we're concerned with, and if yarns don't have a UV stabiliser, they do not last very long. They disintegrate very quickly. So with 20 mil or the 22 mil that's exposed, it has to be UV stabiliser has to be present in the yarns, and that's why the UV tests are important, and even identifying the type of yarn that's in the system to make sure it's got UV stabiliser in it. That's why it's best to do. And most of the manufacturers of yarn systems or yarn products have got all this certification done already. So you're not adding a raft of testing. You can produce certificates for these things. And it's maybe just a question of asking the right questions so that you're protected going forward. So that's why I think UV is an important parameter. And the next question, Sean, do you want what is the minimum tough lock required for textile-based hybrid turf systems?
Yeah, I mentioned that in the presentation. The European standard for 3G systems is currently at 30 newtons, and more rugby and FIFA look for 40 newtons, slightly higher value. Hybrid systems, the ones that we've seen and come across, they can certainly meet the minimum 30 newton requirement. So whether that's right to use, or we should be using the 40 newton like the 3G systems, and these systems can achieve that.
Yeah, and have you seen any that are below 30?
It depends on the aging process as well.
Right.
How they react to that.
Does it depend on the backing at all, or the backing system that's there?
It could potentially be caused by that, yeah.
Yeah, it's interesting. We don't want to disadvantage any products that are in the marketplace because they're probably quite successful, and there are pitches that are operating successfully with them installed. But obviously, I think like anything, you need a standard. We have to set the limit somewhere. If it's going to be 30 newtons, don't want to disadvantage a whole raft of products out there. We're recognising that they've been in the market for a number of years. Quick one there. What's the optimal free pile height for hybrid turf systems? And I mean, that's pitches are regulated by ground staff who cut depending on what team they're playing, whether the goalie wants a slightly higher pile height in the goal mouth or whatever. So it's usually about 20 mil, but you can. It depends on how they're cutting their fields, particularly in football. Okay, next question. Do you want to go back up the list there, Sean?
Yeah.
How long does it take for the build period? Well, depending if you include the grow-in, so the grow-in to a point where you might be able to play on it, it's very dependent on environmental conditions as well, and what time of year you establish the pitch. A build period it's about 12 weeks. So if you look at a programme, you can usually hang your hat around 12 weeks, but there's a lot of caveats to that. So it would be site specific to some extent, and environment would play a big part in that. So there's one from Felipe on is the risk mitigation related to field wear and tear and possible game delays, or risk related to player injury? It's a good question because there has been some issues with textile-based systems going firm early in their life, and and it very much is related to maintenance. So what you have to be aware that is an issue for some of the textile-based systems. You've got to be mindful that they can stiffen up, and obviously that might affect the player surface interaction. But a lot of textile systems, they're there because of wear and tear, and they still look in reasonable condition when a field has had a lot of wear and tear. So that's a benefit of having them, and particularly as you move up the echelons of the league where there's TV involved, that's a big positive from having a hybrid turf system where you've still got a modicum of colour on the surface, even although there might be areas of the field that are fairly badly worn. So I don't know if that answers your question, but that kind of speaks to it a little bit.
So just new ones coming in.
So we're getting a lot of questions now. Given the aggressive nature of renovations on... Oh, you've just closed it down. Given the aggressive nature of renovations on hybrid systems, what are you finding as the average life of a hybrid pitch compared to, say, well-constructed, trained, soil-based pitches? That's a great question. I suppose, there's been a textile-based hybrid turf system around for more than 10 years now. So and it's been quite successful because it's a well-maintained field. I think that the lifespan of these things can be, to a large extent, determined by the maintenance. So there's a lot of aggressive maintenance going on. It's in a stadium setting, and there's a lot of pressure on the stadium to have a lot of turnover in matches. Then the hybrid turf system is going to wear out. It's going to last about 5 years or something like that. Because when you start punching holes in it, you're coring it regularly, it does a lot of damage. So it's always good to look at the warranty you get with the turf system. So when the product's being offered, if you look at the warranty, that kind of speaks to the lifespan of the product. So I can't tell you right now if we look at the 14 different products that we might have seen in the laboratory, what the warranties are, but that would be my advice: is have a look at the warranty the manufacturer's offering. If it's well installed and well maintained, you'll get a long life out of it, but it's probably not going to be much more than 5 years in a high use setting. I think you should take a question now.
Yeah, I'm just going through the ones that are coming in just now, sorry. It's quite a few, a couple there for Dean.
If our technical abilities compromised in answering these questions, we will take them to our colleagues who unfortunately are on the road at the moment. Such is the nature of ProPitch business that we very rarely are in the UK, and even in these very restricted times, there's still a little bit of travel that you can somehow navigate with quarantines, tests, and etc. Which system gives the best anchor for hybrid pitches? Grass reinforced or stitched? That's a good question. You absolutely see a difference in root penetration with the different backing systems. It would be unfair of us to say, oh, that particular product is better than, say, somebody else's product, but we're not in that business today. But certainly you can see quite a difference in the root establishment and the time it takes for root establishment, or based on the different backing systems that are in the marketplace. A stitch system, because of the length of the filament, which is, it penetrates the surface a considerable distance, and when you get good root establishment, you do get some sort of interconnectivity there. The tough log's quite good. You've got a very long filament which is buried in a very stiff matrix, which is basically sand. So the filament's not coming out anytime soon. You generally find in stitch systems it's the yarn's tenacity that gives out eventually. Either it crushes, it fibrillates, or it just folds over and it gets buried. So that's what happens with stitch systems. And with a textile-based system, generally have a lot more filaments per square metre. But burying can be a big problem, and I think Dean mentioned that in his piece.
Somebody asked if it would be available in PDF there. Yeah, we're going to issue this after it's finished, later on today or tomorrow.
What we do, we have other presentations which relate to hybrid turf systems. So what we'll do is they're all I think they're all available on the website. So you can be more than welcome to have a look at any of these videos that are there. This one will go up as soon as we've got time to record it, stick it up there. So in the next 24 hours, I'd imagine it'll be there. So yeah, absolutely. And similarly with the questions, we'll try and we'll take all the questions, and if we can't answer them here, we'll provide some narrative, and we'll just email them back out, or we'll put them on the website, and we'll make a decision on that after this. I thought you were going to answer a question there.
There's a couple there that get Dean or Ian to do something about, but the hardness value between hybrid, stitched and natural. Yeah, we've done a lot of work on that actually. So what about hardness values between hybrid, stitched and natural grass? So I think in 2020 we probably collected over 100,000 data points on what you would call that variety of pitches, and part of the testing regime we carry out is basically collect measurements, but we also use a thing called an advanced artificial athlete, which measures shock absorption and vertical deformation and things like that. So there is a difference. Hybrid pitches would generally be regarded as stiffer than natural grass pitches, and there's not a massive difference between a hybrid textile-based system and a stitch system, because they're both very, very heavily sand-based. So you're picking up the compaction or whatever in the sand more than you would in a natural grass pitch. So I would say that the hybrid pitches, both stitched and textile-based, are generally a bit stiffer than natural grass. So hopefully that answers that question. And we do have data to back that up, and it can be made available anonymized as well. So there is a lot of data on performance of these surfaces. That's about biodegradable back in there.
Yeah, that's a good question.
Yeah. Does the back material need to be biodegradable? No, it doesn't. There are developmental biodegradable backings on at the moment, and these are being assessed, but it doesn't necessarily need to be biodegradable.
I think there's actually quite a few systems that don't have biodegradable backings. I think a few years back it was thought necessary that there was some sort of element of the backing would disintegrate during the very early life of the system, because that would allow the root establishment. But I think that's been dispelled to a large extent. I mean, some of the backings are quite tight, and it does take the root take time for the root establishment. But again, it's different manufacturers' approaches to this, and there's a lot of different materials used in the back end, John, isn't there?
There's a wide range of materials.
You've got linen, and you've got polypropylene, polyester. You've got grids, and you've got textiles. So there's quite a lot of differences out there in the products. What about the organic matter management? Do hybrid pitches create any disadvantage in organic matter layer growth? That's a very topical question. Yeah, I mean, again, that's really a maintenance question. I mean, any pitch can have a problem with black layers forming due to maybe over exuberant treatments or feeding, and so it comes down to the ground care, the staff looking after the surface and really carrying out appropriate treatments and proper maintenance. At the end of the day, we we don't see any particular problem just because it's a hybrid pitch that you get organic layer issues. I mean, there are a lot of these hybrid pitches are starting with 95 to 97% sand content. So your I don't know what's happening with our PowerPoint, but it seems to be.
No, that's separate from us.
Any successful examples of lay play systems? How many times for repeated use? So does that mean how often can you renovate them before you have to take them out and replace them? Is that what that could be? Difficult question to answer that without knowing what that refers to be honest. What's this one from Grant? Is that just the question, or as we go further down?
That's it. So it's, do stitch systems improve infiltration rates of some profiles by the interaction of the fibre to PSD and a sand profile?
Well, I think infiltration rates on stitch systems are generally very, very high to start with, and shouldn't really be a problem if proper maintenance is carried out as the system ages. But obviously, with a textile-based system, you're relying on the back end to a large extent to influence infiltration rates. So if you've got a layered back end with a number of textiles there, the infiltration rate will be slower immediately in that system than say something with a grid or an open textile, like the examples we showed earlier on. So given they're so sand based, you would not expect to see issues with infiltration in the early life of these pitches. And generally speaking, all the sand that's being used is to a PGA spec. So you don't really have a spec for football sand yet, but that might come in these governing body publications later in the year. Might be a sand profile that we can say that's very much for football. So
yeah, and we do test the hybrid systems for porosity as well as part of the assessment. And you do get a variation of results depending on the construction.
So in the lab, you physically take the product.
Yeah.
Is it filled or unfilled? You just take it.
We do it unfilled,
right?
And filled some systems is something we're developing.
Right. So you actually measure how much the runoff runs through the carpet or the textile system, and you get a number for it. So you can say, well, that one's a good one, that one's a bad one, or
or higher and lower value.
Maybe bad's the wrong word, but high or lower. Because we haven't got a standard, obviously. So we don't know if it's bad. It's just when you've got puddles in the pitch that is bad. Is there any other questions up there, Sean?
There's a couple, but
we've kind of avoided the difficult ones, as you can imagine, because we're just a couple of engineers here. We're not running this.
How about Chris?
What we'll do with the two tricky ones is we'll get Dean and Ian onto that, and they can answer these ones offline, as it were. So, any other questions? That there's 4 new ones there. Okay, interesting. So, how does a hybrid pitch?
I'll get public now.
Okay.
We'll go back now. Okay.
How does a hybrid pitch fit in terms of the ECHA microplastic requirement? So at the moment, ECHA's they're looking at intentionally added microplastics and like things like rubber crumb that have been added to a pitch. In a sports setting, they're looking at a lot of other products like exfoliators and fertilizers and various other things. But from our point of view, if you're talking about a pitch and a textile-based or stitch system, then they aren't looking at fibres at the moment. It's not an intentionally added microplastic, it's part of the product. And sometime in the future, they might start to get interested in things that break off from filaments, but at the moment we've got enough issues trying to work around the rubber crumb or pitch and look at the fibres. So that's the good news. It's not an issue at the moment, but watch the space sort of. Do you want to look at
The bottom one, that's the last one I came there. So, are there various levels of recyclability? Are there any plans to certify the process of recycling?
There is obviously, there's a waste hierarchy which is out there, so you can, the biggest benefit to society is to make the product at the start totally recyclable. So that's the first thing we can do, and that's where that would make the subsequent recycling of that product a lot easier. At the moment, we have products that have got mixed plastics in them. When you're looking at textile-based products, so that makes it inherently more difficult to recycle already, and we're kicking the problem down the road as well, because obviously pitch goes in now, 5 years later you take it out and you try and recycle it. So we will see technology adapting in the next 2 or 3 years even that can deal with mixed plastic products. But right now, what happens is the product will go to a plant, it will be shredded up, and where possible they can separate the plastic filaments from the backing, and then that material is then sent to various reprocessors to make secondary products like bins or benches or planks or posts for things that could be, or kickboards or whatever that could be used in sport. I mean, there's been some play equipment made from recycled turf. There's been kicker boards that go around the pitch to rebound boards to keep the infill back in the 3G pitches on the pitch. So stuff like that. So at the moment in the UK, it's basically goes to a plant, is shredded and is taken to be put into secondary products. It can't be made into turf again. Not at the moment. That's coming, but it's a technology step that we need to make to do that. So that's but then, let's face it, the good news is it can be recycled. So that's a good story for the industry, not a bad one. There's another published. That one's in bold. That must be a serious one.
Has never worked with Bermuda grass.
Good question. How does hybrid work with Bermuda grass? Well, I suppose there's a couple of types of Bermuda grass. I mean, we obviously have got a lot of experience of warm season grasses. Certainly, the ones that we've been involved in, we've not seen a significant problem, and they are becoming more popular in countries that have much warmer climate than the UK. I suppose it's one that we could refer to Dean, who's working with a couple of stadiums right now that have got Bermuda grass, grass installed. So we'll take that offline, I think.
I think that a couple of other ones were.
Answered
that
that.
way, yeah.
Oh, here we go. What's that? There's somebody wanting to break the GDPR rules. Can we get all the participants' contact names?
Unfortunately not.
Can't do that, but unfortunately.
That's a repeat one. Okay, answered that one before, so
we run out of questions.
I think so, yeah. I think you've done well with the questions, Eric.
Here's one from Kevin Riley,
Oh,
my old friend, Kevin. You mentioned that examples of turf hybrid pitches have been around for about 10 years or so. So have you tried to put together typical life cycle costs of stitch systems versus the grow and carpet based hybrid systems? We haven't looked at life cycle costs for either system. To be honest, it is pricing and costing is something we don't really get involved in a lot of, because we're not necessarily tendering to have new pitches or renovated pitches installed. But you know, it's a good question. It would be very interesting to have a table where you could have a ready reckoner that says, you know, that system's got long-term advantages over another system. We'd have to get some buy-in from the industry so that they can talk to us about these sort of things. I think if you threw recycling in there as a part of the life cycle analysis, it could get very interesting indeed between a stitch system and a hybrid textile system, because there will be significantly different costs. But sorry, Kevin, this time we haven't got that ready reckoner for you. I'm sure you'll be on the phone in about 20 minutes after this. Okay, so I think I don't think there's any other questions. We've now hit the witching hour. I'd like to thank Sean for organising the webinar and doing all the work on the technical stuff. I just turn up and do these things. It's dead easy for me. But, and I'd also like to thank all of you for coming on. We've had a fantastic number of delegates today. So really appreciate it, everybody. If anybody's got any questions or wants to make any comment or whatever, feel free to get in touch. We're all available, so do that. We'll provide the presentation on our website, and any questions we have failed to answer, we do apologise for, but we will catch up with them very, very quickly after this. So without further comment, we're signing off. Thank you very much.
Thank you.